Hey guys, how you doing? Coach Scott, Purple Wave Chemistries, brothers. How you guys doing? Let's talk about types of solids real quick, right? Types of solids. Hey, we know about solids, but actually, there's a lot of fun, neat things we can do with solids, right? So let's talk about it. Material science. There's two types of solids that we think about. One, something we call amorphous. There's no particular arrangement or no order in how these particles are arranged. Crystalline compounds or crystalline solids are in a very highly ordered arrangement. Okay, so amorphous solids, they're sort of fun. Here's some examples. Rubber, okay, is very amorphous. There's no particular arrangement. Glass, paraffin wax, yeah, cotton candy. These are what we call oftentimes non-Newtonian liquids, non-Newtonian fluids. Crystalline compounds are ionic compounds, of course, and metals and covalent network solids, which we talked about in Unit 5. Crystalline solids are characterized by the bonding type, as we'll see in the next slide. So, these are types of crystalline solids. You have a molecular solid. These are atoms or molecules. What's holding them together? Well, the IMFs holding those together are intermolecular force or LDFs, dipole-dipole, and hydrogen bonds. Properties are very hard and brittle, have a very low melt point usually, poor thermal and electrical conduction. So what are we talking about? Methane, argon, carbon dioxide, uh, glucose, sugar, right? Another one is covalent network compounds. Now, these are atoms. These are also covalent compounds. They're sharing electrons. Now, these are pretty soft usually, low to moderately high melting points, poor thermal and electrical conduction. We're talking about graphite, quartz, rock, diamonds, things like that. Now, ionic compounds. Now, these are electrostatic interactions between the positive and the negative ions, and the force is, of course, the Coulombic force. Right? Very hard, very high melting point, uh, different thermal and electrical conduction, and these are usually salts. Right? Then, of course, metallic solids. Now, these are made up of atoms, okay, and these are, of course, metallic bonds. Now, these can be soft to very hard, and they can have a very low to a very high melting point, and they usually, for the most part, have excellent thermal and electrical conduction. They're very malleable, which means you can bend them, and they're very ductile. So these are all your metallic elements, your copper, iron, aluminum, so on and so forth. So let's talk about covalent networks real quick. Now these are, look at diamond. This is an excellent example of a covalent network compound. All right. So these carbon atoms are covalently bonded to four other carbon atoms. They're sharing electrons. Okay, and these are very hard, and these have very high melting point, the diamond. All right. Now let's look at graphite, another form of carbon. All right. So these carbon atoms are now bonded to three others atoms in a layer of interconnected hexagonal rings. All right. These layers are held together by what? Weak dispersion forces. So those layers will slide easily across one another, which is why graphite is a great lubricant and and part of the lead in pencils. So metallic solids, right? These are not covalently bonded, but there's a serious attraction between these atoms, and it's so much more stronger than van der Waals forces or LDFs, and so we're not going to worry about that. In metals, these valence electrons are delocalized throughout the solid. So this means that these atoms are moving, metallic atoms or metals are moving in a sea of electrons all around the nucleuses of these metals. And these electrons are coming from the valence electrons. Because these valence electrons are delocalized, this accounts for many of the physical properties of metals, which are very important. So, metals are pretty much very good conductors of heat. That's why we can cook with them. And they're very and electricity, and they're very malleable, right? And you can flatten them out, and then they're very ductile. You can draw these metals into very thin wire. So glass is another form of solid. Okay, it's made by melting sand and other minerals at a very hot temperature. They're using 1800 degrees C. Even lightning, if it strikes in sand, okay, it can make a glass. So they can be pretty hot. So anyway, guys, that's what we're going to talk about as far as types of solid, and we can go into much more detail in material sciences. There's ceramics, so on and so forth, and but we're not going to do that right now. We don't really need to do it. So anyway, this is Coach Scott saying "Hullabaloo, Kinnick, and have a great day."